These motors have been in back order for quite a while. This is a 21.5 Trinity X Factor. This is part of the Revtech line. It is a very nice motor. Well, Trinity usually has very nice motors. Now, this batch isn't as clean looking as some of the other motors, so I'm not sure if they were just rushing production or what happened. Maybe they changed factories, I have no idea. But they still perform quite well. But if you look at it, it's 21.5, but they're alright. They're not as clean. They're set at 50 out of the factory. Seems kind of high, but we're going to change the timing. Now, use some pliers, just in the little grooves in there. Stick your pliers in there and turn. These are actually very tight out of the factory. This is really different than the 25.5 motor that I purchased over a year ago. But it's not that difficult. The nice thing is, even if the screws were to, I guess, loosen, your end bell is not going to turn as easily. Now, some motors have a front and a back plate being the end bell. These do not. They only have that end bell, so the back portion. So you remove the rotor through the back. But here we go. So we're going to do the timing testing. Now, this motor has the stock 12.5 millimeter rotor. That would be the diameter. The length of the rotors is the same, all the regular ones. Now, they do make some long versions, which is something to keep in mind. But on this one, actually, this is a long version. The 1119 is a long version. These are rated according to Trinity. They're approximately 1700 Gauss, plus or minus. That's what they say. Well, not bad. Not bad for a stock rotor. Now, if you get rotors that are, for example, a higher diameter, you're going to get less kV. Smaller diameter, more kV. More Gauss, less kV. Less Gauss, more kV. But keep in mind that that also affects the amount of torque. The greater the diameter, assuming Gauss is similar, you'll have more torque, which is why you'll see that crawlers, Trinity may offer a 13 millimeter instead of a 12.5. Or high revving motors, they may offer a 12.3 millimeter instead of a 12.5. So it really depends on the application, the weight of the vehicle, and the intended use. Is this oval, touring, drag car? It really depends. Now, one of the things that I do like about these motors is the timing spread is not that bad. It's actually pretty close, 41, 40, 42, right? Pretty close. Sometimes it'll be spot on, sometimes it'll be off by 1, maybe 2. There's different motors that I've tested, for example, Team Powers, where the spread is quite large. You have about a 6 degree difference between the phases. So that is one nice thing about Trinity. The only thing I'm going to mention about Trinity is you really need to analyze the motor. So when you look at my data table, I generally start with 30 degrees on the end bell, 35, 40, 45. So I go in 5 increments. And the reason why I'm mentioning this is because if you see on the table, say 33 degrees, actually the end bell reads 30. The end bell could say 40, and the analyzer says it's at 35. And this is important because let's say it's the other way. Let's just say it's actually plus 5 degrees, for example, and you set it to 55 degrees. All of a sudden, you're actually running at 60 degrees timing. That means that the motor, the actual rotor, is at the point where it wants to rotate backwards, which is a major issue. You're going to overheat your motor. It's not going to run properly. You're probably going to fry the rotor inside of it. So these are some of the things to keep in mind. The other reason why it's important too is maybe you're running boost and you have your timing at what you think is 45, and then you add the 10 degrees, and that actually, instead of 55, it actually puts you at that 60. So those are things to keep in mind. Or boost. You might be running boost. Now there is a difference between boost and turbo. They both add timing. Boost adds it at a predetermined RPM. So you determine the RPM. Program that into the ESC. Now turbo, that adds extra timing when you're full throttle. So whenever you go full throttle, that's when it adds the timing. So keep those things in mind. Two very useful tools for racing. Bashing, depends. Depends on how exactly you are bashing or what you consider bashing. But again, 21.5 X Factor, this is a motor that I like. If you don't go with Trinity, Phantom makes good motors. I'm running a 17.5 Phantom in my two-wheel drive buggy. I really do like that motor. It's very smooth, very consistent, reliable, and it has plenty of power for a, let's see, it's just over 15 grams. I don't remember the exact mass of that buggy, but it does well. Now, timing again, look at the timing, 48, 47, 48. Very, very nice in timing when it comes to Trinities. Now, I'm going to compare it with some other 21.5s, such as a USGT, just for fun. 21.5 USGT. Those are fixed timing at 30. The one I tested, according to the analyzer, was 29. But I'll compare with a variety of things. And the reason why is I am the guy that showed up one day to a particular track with a USGT car. Yeah, nobody had USGT motors, just throwing that out there. I was way in the back. You will never compete with a USGT motor against guys that are running regular 21.5 motors with a bunch of timing and boost to boot. So keep that in mind. Now this 21.5, this is actually going to go into a Mini. So that'll be fun, a little Tamiya Mini. But here we go. We have the results. Now, like I said, I am going to go into the data table, so we are going into the data table. This is the data for the 21.5 motors that I've tested so far. So our focus is the Trinity X Factor. Now this is a stock with the 1119 rotor, which is a 12.5 millimeter rotor. And we have some previous ones that I've tested. Now this Team Powers, this is an older version. They're in the V4 now. I think it's only the rotor that changed, really. I think that's the major change, other than the aesthetics of the housing. But again, we want to be close to 5, so we would be somewhere between these two as far as amps. And it's kV that we want to focus on, not RPM, because RPM is a product of voltage. That's the reason why. So if your battery's more charged, you'll get more RPM. Now, kV. Well, I guess if it has more charge, it'll provide more voltage. So kV, we are looking somewhere in the 2900 range, so 2900, somewhere around there, and that would be about maybe 52 degrees average timing. See 51 and then 53 average. Now this one had quite a large spread. The Trinity Traxxas, this one 5, so this is the close one. See how high it jumped just in the consumption. Here we are at 2414. So the Team Powers is definitely a better motor than the Traxxas, but it's more than twice the price. This one's about $50 as of the time of this video. This one is about $120. Well, the newer version is. This one used to be about $120. USGT motor, this is just a spec class. I still like putting it on here, but this is average 29 degrees. They're supposed to be fixed at 30, so close enough. This is 1902, barely draws any amperage, so your battery doesn't even know the motor exists. But if we compared something close, let's see this. Oh, actually, USGT does pretty good. Let's see, compared to this. Okay, yeah, there's a difference there. Now, Trinity. So this is our focus right now. We're going to go something close to 5. We don't really have a 5. We have a 4 and a 4.6. And the timing is 48 and 51. So maybe about 49 degrees would be ideal. So we're probably looking at these KVs. It's probably going to be about 2550 kV. which will be that that sweet spot, let's say. So if we say 2550 versus this one, the Powers does have more kV. Now again, that's going to depend on the rotor, also the strength of the magnets, the Gauss. Trinity does publish the Gauss on the rotors that it uses, and I am going to be making a future video when I swap the rotor out on this Trinity. But as it comes out of the box, this is what we have here. So we're looking at about, over 2,400 kV. So probably just over 2,500 kV to be around that 5 amp range looking at these. Thank you very much for watching. I hope this was useful, informative, or at least entertaining. Please subscribe if you have not, and I'll catch you in the next one.
What? Oh, my hair! My tongue! My rod!